All right, class, today we're going to work on a couple more examples of solving rational equations before we move on to graphing rational functions. So in order to solve this rational equation, the first thing I need to do is find the domain of the variable. So that is saying what values would have to be excluded, because remember, I can't divide by 0. In this case, our variable is p, okay? So in order to find the domain, what I need to do is I need to factor the denominators. So I have p squared plus p minus 2. So I need to find the factors of, in this case, AC is going to be 1 times negative 2. So I need to find the factors of negative 2 that add up to 1. And the factors of negative 2 that add up to 1 are going to be 2 and negative 1. And because my leading coefficient is 1, I can rewrite this as p minus 1 times p plus 2. Next, I have 1 over p squared minus 1. Now, p squared is a perfect square, and so is 1, because 1 times 1 is 1. So because this is a sum and difference of two squares, from our rule we learned in section 5.3, I can write this as p plus 1 times p minus 1. This is equal to 7 over 2 times p squared plus 3p plus 2. So I need to find the factors of AC that add up to b. 1 times 2 is 2. So I need to know the factors of 2 that add up to 3. That's going to be 1 and 2. So I know because my leading coefficient is a 1, I can write this as p plus 1 times p plus 2. Okay, so our domain is going to be all values of p, we're working with p, all values of p where each of these denominators is set equal to 0. So I'm going to have to take p minus 1 equal to 0, p plus 2 equal to 0, and p plus 1 equal to 0 in order to determine our domain. So now I have to solve for p by subtracting 1 from both sides. I get p equals negative 1. I add 1 to both sides. I get p equals 1. And I subtract 2 from both sides. I get p equals negative 2. So these are the values that p cannot take on. So our domain is p such that p does not equal negative 1, 1, and negative 2. So there's our domain. And I need to know this because I have to check that the solutions for this rational equation are in the domain. Okay. So now I have this fully factored. I'm going to go ahead and erase down here. So we've got a little bit more room. Okay. So now I need to solve this rational function. And in order to do that, I have to make it so I need to figure out what the least common denominator is of all of these by collecting their common terms and multiply each side by the LCD. So the least common denominator has to have a factor of p minus 1, which we have 2 of. It has to have a factor of p plus 2. It has to have a factor of p plus 1. And it has to have a factor of 2. I'm going to put that in front. So here's our least common denominator. We have a 2 times p minus 1 times p plus 2 times p plus 1. And the reason we do this is if we multiply by the least common denominator, it's going to cause our denominators to cancel out. So if I have 3 over p minus 1 times p plus 2, and we multiply by the LCD on both sides, so I have 2 times p minus 1 times p plus 1 times p plus 2. And over here I'm multiplying by the same thing, 2 times p minus 1 times p plus 1 times p plus 2. Oh, there's just not enough space. My denominators are going to cancel, right? Here, I have p minus 1 is going to cancel, and p plus 2 is going to cancel. So that leaves me with 2p plus 1 times 3. Next, I have 1 times 2p minus 1 p plus 1 times p plus 2, right? And I can see that the p plus 1 and the p minus 1 are going to cancel. So that leaves me with 2 times p plus 2 times 1, which I can ignore. Here, I can see the 2 is going to cancel. The p plus 1 is going to cancel. The p plus 2 is going to cancel. So I'm left with 7p minus 1. Now I can go ahead and distribute. Okay? That's going to give me 7p minus 7. Here I have 2 times 3, which is 6. And then I have 6 times p times 1. So I've got 6p plus 6. Here I have a negative 2, so I've got negative 2p minus 4p. And now I can combine like terms. Over here, 6p minus 2p is going to give me 4p. 6 minus 4 is going to give me a positive 2 equals 7p minus 7. Okay? Now I need to combine like terms. So I want to get all the p's on one side. So I'm going to subtract 7p from both sides. Okay, that's going to leave me with 3p plus 2 minus 7. So I have 3p plus 2 equals a negative 7. Now I need to add 2 to both sides. Nope, I need to subtract 2 from both sides. That leaves me with 3p equals negative 9. I divide both sides by 3, so I get p equals negative 3. All right, I need to check and see if negative 3 was in my domain. My domain was all real numbers except negative 1, 1, and negative 2. So because, a little more time to look at that, sorry. So because p is in my domain, this is our solution. All right, let's work out one final example. So here I have to find the domain of this variable. So I look at my denominators and I see if they can be factored. 3x plus 1, that's fully factored. X is fully factored. So I set each of these equal to 0 to find my domain. So I'm going to take 3x plus 1 equals 0 and x equals 0. I'm going to subtract 1 from both sides. I get 3x equals negative 1, and I divide both sides by 3 to find that x equals negative 1/3. So the two values that x cannot take on, the values that are not in my domain, are when x is 0 and when x is negative 1/3. Now I need to go ahead and solve this problem by multiplying both sides by the lowest common denominator. I need to make sure all factors are taken account. So I have a 3x plus 1 and an x. And then I already have a 3x plus 1 taken care of. So now I'm multiplying both sides by 3x plus 1 times x. So let's go ahead and do that. Okay, I can see on this side the 3x plus 1 is going to cancel out, so I'm left with x times 2, so 2x. Over here, I'm going to see that I have an x which would cancel out. So I have 1 times 3x plus 1 minus, here I have 6x. I can see my 3x plus 1 is going to cancel out, so I'm left with 6x times x, which gives me 6x squared. I'm going to go ahead and combine like terms. I want to get all of the variables on one side of the equation. So I'm going to add 6x to both sides, minus 1, and minus 3x from both sides. So that'll leave me with 6x squared. 2x minus 3x is negative x minus 1 equals 0. So now I know I can factor this, right? I have to find the factors of AC that add up to B. So let's do that on the next slide. I have 6x squared minus x minus 1 equals 0. And I need to find the factors of AC that add up to B. AC in this case is 6 times negative 1, so negative 6, and B is negative 1. So I need to think, okay, so I need to look at some factors of negative 6. Negative 6 is negative 2 times 3. Negative 2 plus 3 gives me a positive 1. Negative 6 is negative 3 times 2. Negative 3 plus 2 gives me a negative 1. All right, we're on the right track. So now I can rewrite, using these factors, our middle term. So I have 6x squared minus 3x plus 2x minus 1 equals 0. Now I need to go ahead and factor by grouping. When we factor by grouping, we're pulling out the greatest common factor. The greatest common factor of 6x squared and 3x is going to be 3x. So 3x times 2x minus 1. And then over here I have a 2x minus 1. And the greatest common factor of 2x and a minus 1 is going to be a positive 1, right? Even if the greatest common factor is 1, we still have to take that factor out. I know I've factored correctly because both of these are the same. I collect the greatest common factors, so I get 3x plus 1 equals 0, and 2x minus 1 equals 0. Oh, guys, I skipped a step. I was thinking too far ahead. Let me back up. So, I collect the greatest common factors. That leaves me with 3x plus 1 times 2x minus 1 equals 0. Now the step I jumped ahead to is using the zero factor property. I know in order to solve for x, I need to set each of these factors equal to 0. So I have 3x plus 1 equals 0 and 2x minus 1 equals 0. This allows me to solve for x. So I'm going to add 1 to both sides. I get 2x equals 1. I divide both sides by 2. I get x equals 1/2. I subtract 1 from both sides. I get 3x equals negative 1. I divide both sides by 3. So x equals negative 1/3. Now, I need to check whether both of these, or one or none, are in my domain. Because remember, it can only be a solution if one of these values, if the value is not in our domain. Well, our domain is all real numbers except for when x is 0 and x is negative 1/3. Well, negative 1/3, that's one of the solutions that we found. So this is not a solution. That means our only solution to this rational equation, is when x equals 1/2.